Okay, so let's have a look at the problem 4.22 of Griffiths, third edition. Now, to solve this problem, we need to remember some problems that we already solved. What is it that we need to remember? First, a problem that we solved in chapter 3, the problem 3.14. What did we learn there? Some properties of commutators. So we learned that when we had the sum of two operators, A plus B, and we are checking the commutator with C, then we open this sum. So then we have A with C and then B with C. So you show that in this problem. The other property is when you have the product of two commutators A and B with C, then you learn that this first one, you take it out in front and check the commutator between B and C. And this second one, you take it out, but you put it at the end. So first you have the commutator between A and C, and then you multiply it by B. Okay. The other important thing that we need to remember is what you can find in the equation 4.96 in the book, where we wrote the components of the angular momentum. So the angular momentum are cross product with P. You know how to obtain. From this, you know how to obtain the components. So I'm just going to write them here because we'll be using them. Okay. Well, and these are things that you already did and know how to do. XPZ and find LZ is X with PY minus Y with PX. Okay. Now, these are commutators, and we know that commutator X and P is not zero, is IH bar. And we know that if we, and careful here, because this is X with which P? Now is PX, okay? And if we change the order, if we check PX with X, this is going to be minus IH bar. And this is true for all other directions. Y with PY will give us IH bar and inverting the positions minus. And Z with PZ will give us IH bar. Now careful, you cannot mix directions. If you check X with PY, oh, this is zero. Okay, same thing if you check Y with PZ and so on. Now, if you do commutators between any piece, PX with itself is zero, PX with PY is zero, and if you do the coordinates X with Y is zero and so on. So the only thing that really survives is X with P in the same direction. Okay, we remember all this, now we can go for the problem. So problem 4.22. The first item there, the item A, is to check the commutators of LZ with all other components, now with X, with PX, with Y, PY, Z, and PZ. Let's start with one of them. Let's do one of them. LZ with X, commutators. And what we have to show is that this is equal to IH bar Y. Okay, so how do we do that? Well, here in front, wherever I have LZ, I'm going to pick what we wrote here, LZ. So let's write it here. Instead of LZ, I'm going to write what we have there, X PY minus Y PX. Yeah? And we have here X. Now, what the next step? I'm going to use this property here to open the commutators. Now this product, this property of the sum, I'm going to use it here for the subtraction. So I have X, P, Y with X minus y px x. Okay, all right. And what we are going to do next? Well, next I'm going to use this other property of the case where we have the product between operators. Okay, so here the x shows up in the first position, so I'm going to take it out of the commutator, put it in front of everything, py x. Now I'll do it again, but now with the py, I'll take it out and put it to the end. So it will first have the commutator x with x, and the py goes to the end. Okay, same procedure now with the second commutator. This y is in front, it comes out first, pxx, and then this px goes to the end, so minus y x p x. Very good. So now let's have a look at what we have of each one of these commutators. Well, this first one, 0, because we have y, py with x, this is 0, different directions. Here, x with x is 0, is the same quantity. This one, this one is very good. This one is what we showed here. It's not 0, it's minus I h bar. So let's put here minus I h bar. And the last one is y with x. This is also 0. So you see, we obtained exactly what we wanted. Minus with minus gives us plus I h bar y. And you can continue with this procedure for all the other cases, and you will find the results that are given there in the problem. Now, let's have a look at part B of this problem. Part B of this problem is now that we know how LZ, the commutator between LZ and all these other elements, now all these other operators, x, p, x, y, b, y, and so on, show that LZ with the angular momentum in the x direction gives us I h bar Ly. Okay, we already did this in class. I'm going to repeat how we did in class, and then we are going to solve the way that the problem is asking us to do it. Okay, but either way, they are of course equivalent. So first we are going to write what LZ is. So we come back to our notes, let's write what LZ is, and we are checking the commutator between LZ and LX. So I'm going to substitute the two with x and py and pz and so on. So let's do that. So LZ is xpy minus ypx, and Lx is ypz minus zpy. So this is how we did in class. I'm just going to review that with you, and then we'll solve the way that the problem wants us to do. So what are we going to do? Well, open these commutators now, following according to this subtraction. So that means we'll have x py with, no, so this first term with this one, y pz. Okay, then we have this first term with this one. So minus x py with z py. Then we have this with this. So minus ypx with ypz. And finally, the last one, this one with this one. So minus and minus gives us plus ypx zpy. Okay, now what is the next step? To go on opening these products in these commutators. But before going to all that, let's have a look at which commutators we really care about. Let's look at this first one. Look, here we have x, and we don't see anywhere a px. So we have pz, and we don't see anywhere a z. But what is important in this story? Oops, this combination here. Yeah, very good. Now let's go to the next commutator. The next commutator, we have x, and we don't have any px. We have py, and we don't have any y. We have z, and we don't have any pz. We have py, and we don't have any y. So we don't need to open this. We don't need to waste our time. We know this is 0. Let's see the next one. Well, y and no py, px and no x, pz and no z. So we know this is 0. Now, the last one, let's see. This one is the one that is also good because we have y here and py. Okay, so we only need to care about these two remaining commutators. And let's go with the properties. So here we'll put x in front, py with y, pz. So I'm working with this guy here. And then I'm going to put x, y, pz, and the py at the end. And so first I put this guy in front, and then I put this one at the end. Okay, and then we'll have to open this again. But let me go to the last commutator that we have there. I'm going to put y, px with z, py. So I'm working now with this. And I'm going to put y, z, py with px, which means I'm working with this guy. Okay, so let's see in these commutators what is interesting for us and what can we already cut perhaps. The first commutator, this is good. I see here py and y. We keep. Now, the second one, look, we have x, y, pz. They all commute. Now let's see this third commutator, px, z, py. They all commute. And but here the last one, this is interesting. All right, so let's continue with our game. So this first commutator, I'm going to put x. If I bring this y here to the front, I have y, py, pz. And so what I'm doing is I'm bringing this to the front. And then we have x, py, y, and pz to the end. Okay, so now I moved this one. And the last commutator, we have z, I bring to the front, y, py, px. Oops, yeah. So this is what I brought to the front. And then plus y, z, py, px. And this is the one that we took to the end. All right, so let's have a look at what we have now. This first guy, 0. Different directions, p with p, 0. This one now, very important, minus IH bar. This survives. Let's go to the next one. This very good, this survive, IH bar. The last one, gone. Y with Z is 0. So let's see what survived in this story. We have minus IH bar of X with PZ. And we have plus IH bar of Z with PX. So we can write this as IH bar ZPX minus XPZ. This is IH bar of LY. Okay, if you go back to what we wrote here, you will see that we obtained this LY. Okay, very good. So we arrived where we wanted. But the other way to arrive at the same answer is using these results that we obtained for item A, where we obtain the commutator, and I'm going to write here, well, you can obtain the commutator between Z and X and Z and PX, PY, and then LZ with a Y and LZ with PY. So let's write what the answers are. Here we also have a minus. And then finally, LZ with Z and LZ with PZ, you can show that this is 0. Okay, so using this, the other, so we can use these results here to show what we just did, that the commutator between LZ and LX is IH bar LY. So it's going to be a little faster because we already have these results. And so what does it mean? Instead of write what LZ is, I'm just going to keep it as LZ. But I'm going to write what the LX is. So the LX is XPY. Oops, sorry. LX is YPZ minus ZPY. So what do we need to do? The commutator between LZ with YPZ and the commutator between LZ and ZPY. Now look, here we know that LZ with Z is 0, that LZ with PZ is 0. So I'm not even going to bother keeping this commutator or this commutator. So the only thing that we need now is LZ with Y, and let's move that PZ to the end. And in the second case, we are just going to keep LZ with PY, and let's move the Z to the front. So this PZ was second, it went to the end. This Z was first, it went to the beginning. Okay, and now these two commutators we already solved. So that was the purpose of problem of item A. So LZ with Y, so LZ with Y is this one. So let's write the answer. Minus IH bar X with PC. Minus Z. And now this other commutator LZ with PY is here. So it's minus IH bar PX. So let's organize these things. What we have, well, this minus with minus will give us plus. So I'm going to start with this term here, which is positive, IH bar, and we have Z PX, and now minus this, minus X PZ. So you see it was faster this time. This term that we see here is the LY. So it was faster because we already had the support from these commutators. Okay, very well. Now, this is item B. So this is item B. Item C. Item C is just using everything that we already did above. And so one of the commutators that we need to show is LZ with R squared. But what is R squared? R squared is x squared plus y squared plus z squared. So what do we have to do here? LZ with x squared plus LZ with y squared plus LZ with z squared. And how do we proceed here? Well, it's the product x with x, y with y. So we have to use that property that we saw above. And so what we have here is x with x. So one x comes to the front and one x goes to the end. Okay, so what we are doing, this first came to the front, this second came to the end. And you go on with all the others in the same way. LZ with y, and the same thing for the z. And then you substitute what we saw before for each one of these commutators, okay? So that's the idea. And then the same thing, similarly, you do that for p squared. What you have to do? Well, substitute p squared by px squared plus py squared plus pz squared and open the commutators as we did above. Final item, this one is a little it's a little bit more involved because what they want us to do is to show that the Hamiltonian, so this is the Hamiltonian, commutes with all three components of the angular moment. So we want to show that the Hamiltonian with Lx is 0, the Hamiltonian with Ly is 0, the Hamiltonian with Lz is 0. Okay, and but what is the condition here? That this potential energy depends only on R. Okay, and what is R? R is x squared plus y squared plus z squared, but the square root of all this. Okay, so this is the annoying part, to have to deal with this square root. Okay, so the way to go here is pick each one of those components and, well, first look at the commutator with p squared. Yeah, so get the commutator of Lx, of Ly, of Lz with p squared. Okay, so, but this we already know how to do. And then, so you get the commutator for this part of the Hamiltonian. The second part is to check the commutator for the part involving the potential. And this is the part that is a little bit more annoying because you have to deal with this R. So let's do just one for you to get an idea on how to do. And so we'll need to play with the commutator of Lz with the R of the potential. And how do we obtain that? Well, here is using again an auxiliary function, as we used to do, as we did when we showed that x and p is IH bar, by using this auxiliary function. And how do we go? Well, let me write this again here to get more space. How do we go? Well, first, let's write what this operator Lz is, but using that momentum is minus IH bar ddx or y or z, depending on the direction. Okay, so if we use that, this commutator will become this x. Okay, so what I'm doing is Lz is x py minus y px. Okay, so I'm writing this py and this px using this form. So then we have ddy minus y and the partial derivative in x, r, and the function. All right, so now let's use the property of commutator. And what is the property of commutator? A commutator with b is ab minus ba. So this is what I'm going to use here. So now we have, but also since we have a derivative, this derivative will be applied on r and also on the function that we have. Okay, so if you do that, we'll have I minus I h bar, and then comes x with that derivative r and f dy. Yeah? And then y, and then the derivative in x of r and f. So this was this first part of the commutator. But now let's go for the inverted order. That gives us a minus sign, right? So we'll have here minus. We'll have here minus. Now r came, this r here is now in front. Yeah? R, and then we have x, and then the derivative of that auxiliary function. Minus with minus gives us plus r, y, and that derivative. Okay, very well. What is going to survive in this story? Look, when you do the, when you take this r, when you're doing this derivative and you take the r out, the derivative that survives in f will cancel this one. And the same thing with this. When you take this out, this derivative that survives in f will cancel with this one. So the only thing that will survive in that story, let's write it here, is the x of the derivative in r with the f outside, and the y, the derivative in x of r, okay, with this f outside. All right, now, if you go on and check what is this derivative of x and y. Well, let's start with the x. What is r? Is what we wrote above. No? So what we are doing here is this derivative of the square root, x squared plus y squared plus z squared. Okay? And if you do this derivative, what you're going to get? Well, 1 over 2. This whole square root will become minus half, so it will go down here. And the derivative of what is inside gives us 2x. So this is x over r. And you can do the same for this derivative in y. And finally, if you go through all that, you will find the LZ, the commutator LZR is actually 0. Okay, so you can do that, the same procedure for all the other directions.